In this section, we will study perhaps the single most powerful tool for differentiation, the chain rule for differentiating composite functions. The chain rule states that if y equals f of u equals g of x, and the derivatives dy du and du dx both exist, then the composite function defined by y equals f of x of g of x has the derivative given by dy dx equals dy du times du dx, which equals f prime of u times f prime of, g prime of x, equaling f prime of g of x times g prime of x. This is a lot simpler when used with numbers. For example, we can use a variable to solve this. Find dy dx if y equals the square root of u and u equals x squared plus 1. Well, we start out by substituting. Y equals the square root of x squared plus 1, which we can also write, we know, as x squared plus 1 to the 1/2. To find y prime, we take that 1/2 and do the derivative like that, but we have to remember to take the derivative of the inside, what is in here as well. So we multiply that by 2x, which is the derivative of x squared plus 1. And then we simplify to find that y prime is 2x over 2 root x squared plus 1. 2's cancel, and the derivative found using the chain rule is x over x squared plus 1. Another rule similar to the chain rule is the power rule, in which y is u to the n and u is a function g of x. To solve this, to find this derivative of g of x to the n, we do the same, multiply the n, and then subtract 1 from the numerator, but then we must also remember to find what is inside, the derivative of the inside function g of x. With numbers, this is illustrated as this. So we have here f of x equals x to the 5th minus 4x plus 8 to the 7th. So there is a function raised to a power. First, we find y prime by taking the 7 down and subtracting 1. However, we're not done, because since this is a function, we need to multiply by the derivative of the inside, 5x to the 4th minus 4. The final derivative would be a composite of these, but for time's sake, we're not going to write it all out. The important thing is that we remember to find the derivative of what is inside, 5x to the 4th minus 4. Here's another example. In this example, we must use the chain rule to find y prime. So we have y equals u squared, but u is x cubed minus 4. We then use the power rule, and we cannot forget to multiply by what is inside, 3x squared, so that y prime is 6x squared times x cubed minus 4. Here's another example. We multiply by the outside first, and then the inside, 2x minus 3. And that is that.